Hello, guys. How are you? Okay, I hope you guys are doing well. Okay, so today we are going to start linked list. Okay, so in this lecture, we learn about linked list. Okay, what is linked list? Okay, how many type of linked list? So first of all, I need to start linked list. Okay, so we will know what is the node inside the linked list, or how to create node inside the linked list, and how to create class. Okay, and we will also know about the difference between array and linked list. Okay, and we will also create some program on this linked list. Okay, like string method. Okay, append method, prepend method, traverse method, insert in the beginning, insert at the middle, insert at the end. Okay, so if you want to learn linked list, then you can watch this video till the end. Or we will also we will also complete method like search method, how to search element inside the linked list. Okay, get method, how to get element by using linked list. Okay, set method, how to insert method, like if we have index, then we want to put like I have index 1, so I want to replace index 1 element with the another element. Okay, and like how to set values in linked list. Okay, so we will see different things, or pop method first, pop first, pop last. Okay, so if you want to learn these things or different method, so you will continue with me. Okay, so I am going to start. First of all, I need to start what is the linked list. A linked list is a data structure that store in a nodes. Okay, it is a data structure that is stored in the nodes. It's like a chain, multiple nodes connected in a chain. Okay, each node has data and next pointer. Data means value of node. Okay, next pointer means address. Okay, so or we can see linked list versus array. So that we want to know difference between linked list and array. So our array in Python, it has element at continuous location. Okay, continuously we can put element here, and its memory is continuous. Okay, index is with the help of array we will do fast indexing. Okay, we can access the element like this, array at index 1 what we have. Okay, so it will give you like for example we have 20, so it will give you array at index 1 we have 20. Okay, so linked list is a scattered in memory. It has a like a bell data or next pointer. Okay, it is not fast. Okay, linked list is not fast, it accessing element slowly, but array is fast. Okay, array has fast indexing but slow in insert and delete in the array. But linked list is slow indexing and fast insert and delete. Okay, use array if you need fast access, and use linked list if you need frequent or insertion deletion. Okay, so I am going to share my screen with you, but before you need to know type of linked list. Okay, so we will learn type of linked list, how many type it has, like singular linked list, double linked list. Okay, circular singular linked list, circular double linked list. Okay, so here I'm going to share my screen with you. Okay, so I hope everything is visible. Okay, so we have linked list is a data structure that store the nodes. Okay, so each node has data. Okay, and next pointer, data means any value, thus be these like this. Okay, 10, 20, 30, and next pointer means point reference of the next node. Okay, so unlike array, list element are not stored in a continuous memory location. For example, we have this one is a head of linked list. This is the data and this is the next node. Okay. Again, you can see it connect with the arrow and 20 and next, 30 and next, none. Okay. Every node is connected by the arrow. Okay. First node is head and last node is tail. Okay. Or you can say none. Okay, a linked list consists of the node with some sort of data and pointer of linked list to the next node. Okay, so here this is the data. Data means value like 10, 20, 30. Okay, and next pointer are used to connect with the next node. Okay, next node. So here again data and next node. Here you can see third node data and next data and next. Each node connected. Sorry, each next point connect with the another next node. Okay, or here you can see difference between linked list and array. Okay, so array is continuous, indexing is also fast. Okay, so if you want to access, okay, this is the array, for example 10, 20 and 30. Okay, inside list I have 10 comma 20 comma 30. If I want to access index 1, okay, so array and square bracket 1, so it will give you index 20, so it has fast indexing. Okay, linked list scattered in memory. We can't access fast element inside the linked list. Okay, so here head 10 next arrow 20 arrow 30 and none. Okay, so array has fast indexing, slow insert and delete. Okay, but it has slow insert and delete. If we want to delete or insert the element, we need to use loops, or we can use method, insert method, delete method. Okay, in linked list slow indexing but fast insertion and deletion. Okay, use array if you need fast access, and use linked list if you need frequently insertion deletion. Okay, so type of linked list, single linked list. Okay, so every element connected as a chain. First node is connected with the two second node is connected with the third node is connected with the fourth node connected with the fifth node. Okay, so each node point to the next node only. Okay, here by arrow. Okay, so first node is head and last node is, you can say, tail or none. Okay, and double linked list, each node has two pointer, previous and next. Okay, none, this is the node 10. Okay, it has next pointer, and 20 again it has previous pointer, next pointer and 30, none. Okay, here you can see in diagram I have a maze. Okay, one first node, it will connect with the second node, but it has two pointer, previous pointer and next pointer. Again you can see node 3 connect with the previous node 2, and 2 is connected with the next node with the 3. Okay, so here you can see to store the data value, like if it is your data. Okay, this is for previous, it stored the address of the previous node, and this is to store the address of the next node. Okay, circular link list, last node point back to the head from a circular. Okay, like if you have a nodes, different nodes, data and next, data and next, data and next. Okay, so this is the last node. Okay, so this last node point back to the first node. Here you can see, here last node point back to the first node, because you can see here it will make circular after connecting last node to the first node, it will make circle. Okay, that's why it is called a circular linked list. Okay, here you can see we have 10, 20 and 30. If we back to the 10, then it will become circular. Okay, here you can see singular linked list, circular singular linked list, this one. Okay, and here this is the double linked list, circular double linked list. Okay, it has previous and next pointers. Okay, so here I have one node, two node, three node, each node have previous and next pointer. And here you can see first node, sorry, this first node is connected to the last node. Here you can see this first node is connected to the last node, and last node point back to the head. Okay, so head is connected to the tail, and this tail is connected to the head. So this is called a double circular linked list. Okay, it has next pointer, previous pointer, next pointer, previous pointer in each node. Okay, And here we can see array in memory. Array element are stored continuous memory. Okay, so we have different index. Okay, so we have value at index 10, sorry, at index 0 we have 10, at index 1 we have 20, at index 2 we have 30, and at index 3 we have 40. Okay, so these are the address 100, 104, and 108, and 112 for these element respective. Okay, so linked list in memory. Linked list element are stored as a node. Each node has two pointer data. I already explained data like value dot 120, 10, 20, 30, or whatever. Okay, and point means next memory address of the next node. Memory address of the next node. Okay, so node look like this data and next. Okay, for example, we have had node 1, node 2, and node 3, and node 5. Okay, so head point to the first node. So first node in linked list should be a head, and last node should be a tail or none. each node point each node point to the next node. Okay, so node are not stored continuously. When you create node, it get memory from any free space in RAM. Okay, for example, we have a scattered node 1 data, it had value 1, and its address is 200. Node 2 data has 2, and address equals to 540. And node 3 has data 4, address equals to 120. Data equals to 5, address equals to 999. Okay, they are scattered, but linked list use the next pointer. Extra memory is used for the store the pointer in linked list. Okay, dynamic sizing. Unlike the array, we don't fix the size of at the start. Okay, access is slower, must travel from the head node and node. Okay, so that's why it is slow. Okay, so difference from array. So array has fast access and fixed size, and linked list is slow and dynamic. Okay, so this is our single linked list. This is the data, and this is the next, and this is the head. Again, we have data. This is the next. Again, we have data, and this is the next. Again, we have data, and this is the next, and null, or you can say tail. Okay, so first of all, I'm going to create node. How to create this node? First node, this node, a, and next. Okay, so here I'm going to create node. So I'm going to put value equals to 10, means data equals to 10. Okay, I mean a equals to 10. Okay, here a, and next is none. Okay, so new node dot value equals to 10, and new node dot next equals to none. Okay, you will got it everything. Wait a minute. Okay, so value equals to 10, and next value equals to none. So if you are going to create new node, okay, new node means this dabba. If you want to create initially, okay, so initially we don't have anything. So first of all, I'm going to check it is running or properly not. Let me check. I need to select what my kernel. Okay, it is working fine. Okay, guys, so first of all, I need to create one class equals to node. Okay, and here I'm going to define one function, that is constructor. Method, you can say method. Okay, here I'm going to pass, oh, what the hell, I need to remove this. But here after self, I need to put value as a parameter. Okay, because I'm going to create first node, and it has value that is 10. Okay, and here I'm going to create variable, that is self dot value. Self dot value equals to value. Oh, not value error, it is value. And self dot next, self dot next equals to none. Okay, you already see this. First of all, like if we don't have anything, we want to create this node a, and it has a equals to value, and value equals to 10, and next node we don't want to connect no, next node. Okay, so that's why it is none. Okay, and this is used for store the data, this value, and initialize no next node. Okay, we just want one node that has value 10. Okay, so for example, I am going to create object. So that is new node. New node equals to node. Node value is 10. Okay. And here I'm going to print. I'm going to print what? Node created with value, comma. Here I'm going to pass new node dot value. Okay. That we got value from here. Okay. And here again for this is for next pointer. New node dot next. I'm going to run. So I got this node created with value 10 and next pointer is none. Okay, guys. So node created value 10 and next pointer is none. Okay, so you can create node like this. Okay, so you also add multiple nodes here. And here you can see the node class represent the single element in the linked list. This node class. Okay, each node has value. The data is stored in the node, and next node, next pointer connects a pointer to the next node in the list. Okay, so initially we initialize none. Okay, so now we are going to create linked list class. Okay, so if we don't have like any linked list, okay, so you can say we have zero. Okay, length is zero. So first of all, head is also none and tail is none, means we don't have any head and tail. We do not have anything head or tail. Okay, so we first of all we initiate linked list class. So okay, how can we do this? Okay, so first of all I need to create one class equals to linked list. What the hell? link Linked list. Okay, and here I'm going to define a constructor that is init. Here I'm going to pass self column. I'm going to create self dot head. Okay, so we don't have any head because its length is zero. Linked list length is zero, so we give here what? We will provide here none. No any none. I need to copy this. Again, I need to write self dot tail. It is also none because we don't have any tail. And self dot length length equals to 0. Okay, so this is our linked list with 0 length. Okay, so we can create self dot head equals to none, self dot tail equals to also none, and self dot length equals to 0. So initial state head and tail are none or empty because we have empty linked list. Okay, and length is 0. So linked list class manage the nodes. Okay, now we are going to move on str method. Okay, it convert your linked list object into readable string. Okay, it convert your linked list object into a readable string that show all element in order and connected by the arrow. Okay, so here we have linked list 10, 20, 30, and 40. Okay, so first node of linked list should be a head. So that's why we have head equals to 10. Okay, in this linked list. Okay, and last element should be tail. Okay, so 40 is tail of this linked list. Okay, but this is the head and this is the tail. Okay, here I am going to create one variable temp node equals to self dot head, this head. Okay, so temp node will become 10 now. Okay, I'm going to create this variable. Okay, so we will move this temp node from here to here to here and reach there. Okay, okay, we can access the element like this with the help of 10 temp node. Okay, so temp node equals to self dot head. Okay, self dot head, what is the self dot head? That is 10, and result should be empty. Okay, so here I'm going to write code, then you can understand everything. I'm going to define one function, that is str, or you can say method str. Okay, and here self, I'm going to pass self colon. Okay, so I'm going to create temp node. Temp underscore node. Temp underscore node equals to self dot head. What? Temp node equals to self dot head. And result should be empty because we will store here everything. Okay, one by one. Here I am going to use loop. Okay, while temp node, what the hell, temp underscore node is not none. Okay, so I already said that. What, this is our temp node. What is the temp node? Self dot head. This is our first node will become temp node now. Okay, so here I create one variable temp node equals to self dot head. Okay, in our linked list first element is 10, so temp node equals to 10. Okay, here this like this. Okay, and result should be empty, that we can store upcoming result like this. Okay, so in first station we need to check temp node equals to node 10. Okay, so while temp node is not none, this condition is true. Temp, while temp node is not none, of course temp is not none because we have 10. Obviously we have 10 here, you can see here. Okay, then what we are doing, we are doing this. Inside the result I am going to store this 10. Okay, so result equals to result plus string temp node value. Okay, I am going to store this 10 inside the result. So here I am going to create this line result plus equals to str. What is str? It will create a new string object from the given object. Okay, so you can read this. Okay, so here result equals to result plus string temp node dot value. So we will got here value. Okay, okay, temp node dot value. So we store 10 inside the result. Here in first step, you can see here now result equals to 10. This should be in string, double quotes, because we are going to use string here. Here you can see I use string. Okay, so we got 10 here in result. Okay, now what we are going to do, I'm going to check if temp underscore node dot next is not none. Means after temp, this is our temp node. Okay, so we will search temp underscore node dot next means 20. If it is not none, then we will execute other condition. Okay, so of course temp underscore node dot next means 20. It is also none because we have 20 here. Okay, in this condition, if temp underscore node dot next is not none, this condition is true because we have 20. You can see here we have 20. Okay, so here I'm going to write this condition. If temp underscore node dot next is not none, of course it is not none because we have 20. Okay, then what will I do? I'm going to use result equals to result plus plus in string I'm going to add arrow. Okay, so here you can see I'm going to add arrow result plus result equals to result plus arrow. Okay, so before what we have 10, and I'm going to add here arrow. So like if we have, oh, I remove plus from here. Okay, so previously we have 10 inside the result, so it is like a result equals to result plus, and we'll add arrow. It is like this. Okay, so in result what we have 10. Okay, now I am going to add what? I'm going to add arrow like this. Okay, so it will become what? It will become in double quotes 10, and after 10 it will give you arrow. Oh, like this. Okay, so here result equals to result plus this arrow, so it will give you 10 arrow. Okay, and here 20. Okay, so it will add 20 here. Here you can see after arrow it will like this. So you can also write 20 here. Now we are going to move in another step, that is what? Temp equals to, temp underscore node equals to temp underscore node equals to temp node dot next. Okay, so we can see here another element inside the linked list. Third, temp node equals to temp node dot next equals to 20, 30, and 40. Okay, so move to the next node. This is our first step. Here I am going to move in the node 30. Okay, I have finished with 20. Now we will move on 30. Okay, in first step, I just add arrow, and we move here in 20. Okay, and again we check to do is not none, temp dot next is not none. Okay, I already explained these things. Okay, and here again I can see if node dot next is not none, so yes, next node is what? 30 here, this 30. Okay, so it is also not none. Okay, so we add the arrow here. Okay, and we move on next node, that is 30 here. Okay, so we will connect with 10 with 20 and 20 with 40 and 30, whatever you have in link list, by using this step. Okay, so first of all, you need to create head and tail in linked list and create temp node self dot head. Okay, this is our linked list, this is the temp node, first temp node, and this is the temp node dot next. Okay, so you need to check both condition while temp node is not none. Okay, because we have 10 initially. Okay, so it will this value will add in result. Okay, again you need to check temp node dot next, this 20 is not none. Yes, not none, because we have 20, this is true. Okay, so we need to add arrow here. Okay, again we need to use this condition temp node equals to temp dot next, it will move on 20. Okay, and again we can check, what we can check, this condition while temp node is not none. Okay, because 20 is not none, and we add this 20 inside the result. After 10 we add 20 here. Okay, if temp node dot next is not none, because we have 30, you can see here after 20 we have 30, temp node dot next. Okay, so this will become again temp dot next. Okay, again we add arrow here, and now next temp node will become 30. Okay, move to the next node, that is 30. And here you can also check temp node dot value equals to 10. Okay, temp node dot next equals to 20 with arrow. Okay, we can check, we can add 10 plus arrow, so it will become 10 and arrow, or it will give you 20. This is the first step. Now we move temp dot node value, we can check again here. Okay, 20, that 20 is not none, so yes, it is not none. Okay, we can check temp dot next, this is this 30, temp dot next is not none, this is 30. Okay, so we add 20 with arrow. Okay, so here you can see next temp node equals to 30. Okay guys, so you can create code like this. Okay, condition equals to temp no none, so by loop stop and return 10, 20 and 30. Okay, so I hope you got it. Now we are going to add element inside the linked list by using append. Okay, so we have head equals to none and tail equals to none and length equals to 0. Okay, so we initially have linked list element none, head, tail, and length is also none. Okay, this is the append method. So we are going to start with empty, because we don't have anything, not head, not tail, and not length. Okay, so initially we have empty linked list. Length equals to 0. Append means add karna. We are going to add something. I mean, we are going to add element. So we are going to add 10 here. Okay, so here, after adding this 10 here, this 10 will become head and tail. Okay, this is also head and this is also tail. And we are after appending 10, I'm going to append 20. Okay, after 10, I'm going to append 20 here. So 10 will become head and 20 will become tail. Okay, append means we are going to add element one by one in the end of element. Okay, I have 10, so I want to add 20 inside like in the tail, or you can say end of the linked list. Okay, after 10 I'm going to add 20, so head will become 10 and 20 will become tail. Tail move to the 20. Now I am going to append 30, so head equals to 10 and tail move to the 30. Okay, because 30 is last element. We are going to add every element inside the linked list at last, or you can say at the end. Okay, I'm going to append 40, so 10 will become head, 20, 30 and 40. 40 should be tail, because tail move to the 40. Okay, so first of all you need to create empty linked list that has head equals to none, tail equals to none and length equals to 0. Okay, I'm going to explain again. Okay, so append equals to 10, I'm going to append 10, so head will become 10 and 10 also, tail also will become 10, and length is its length is 1, because I have one element. Okay, I'm going to append 20, so head is 10 and 20 is tail and its length is 2 because we have two elements inside this. I'm going to append 30. Head is 10. Okay, 20 and 30 is tail. Its length is 3. Okay, guys. So this is the process you need to follow. Create a new node. Check if the linked list is empty. If empty, set node both head and tail. None. If not empty, connect to the current tail and then update the tail. Increase its length and done. Okay. So here, first of all, I'm going to create append method. So I'm going to create one function def append. Okay, here inside this I'm going to pass self comma value colon new node new underscore node equals to node because we are going to create nodes. Here I'm going to, with the help of nodes we can create a value. Okay, like 10, 30, like this 10, 20 and 30 after adding. Okay, here I'm going to create variable if sorry if not if self dot head is none. If self dot head is none, initially if we have head is none, then we need to self we need to sorry we need to set not self. So it will become self dot head equals to new node because we are going to add new node because head is empty or head is none initially. Okay, so I'm going to add one element that is self dot head equals to new node. Similarly we can add tail. So self dot tail equals to new node. Self dot tail equals to new node. Okay, and here in else condition, okay, this is this condition for empty linked list. If you don't have any node, okay, who has head or who has tail, so it is, if both are none, then you need to create head and tail with the new node. New node means you can put any value. Okay, otherwise if your linked list is not none, then you follow this, what, this self dot tail means what? If you have linked list, mm, like this, okay, means we have one element. For example, our linked list is not empty, but we have one element inside this, like 10. Okay, so you add the element in the tail. Okay, so I have 10, I am going to add 20, so 20 is the new node dot next, sorry, this is the new node. Okay, so here self dot tail dot next equals to new node. It's mean self dot tail dot next means I am going to write here I have 10. Suppose we have 10, it has like a tail and head both on 10. Okay, head equals to 10 and tail equals to 10. I means we have length, some length. Okay, then tail dot next. Okay, so this is also tail and this is also head, so I'm going to suppose this is the tail. Okay, tail, so 10 is the tail and next means arrow. Tail dot next, I'm going to add here new element that is 20. Okay, so tail dot next equals to new element, or you can say here like this 10 dot next equals to new node that is 20. Okay, 10 dot next equals to 20, so it will become like this: 10 arrow 20. Okay, now I am going to set, because I have tail and head in same point, that is same node, that is 10. Okay, now I am going to set that 20 is tail. Okay, because now no 10 is no more tail. So here I am going to set self dot tail is equals to new node, because our new node is 20. This will become our new tail. Okay, so here 20 is our tail. And here if you got confused, I'm going to write here after 10 we have 20 here with the help of this line. Self dot tail dot next, I'm going to add new node, that is 20. Okay, now this new node will become tail. So self dot tail equals to new node. Okay, and I'm going to increase its length by 1, because I add what? I add one element. So I increase it by 1. Okay, guys, I hope you got it. I'm going to again explain. Okay, so append 20 if link list is empty. Okay, so head equals to none and tail equals to none. Initially, we have head equals to none and 10 tail equals to also none. So after adding 10, so head equals to new node means 10. I'm going to explain again everything. Okay, and tail also equals to new node. New node means 10. Okay, 10 become both head and tail. Okay, so head equals to 10, tail equals to 10, linked list is 10, and length is equals to 1. Now we are going to append 20. We can check here. Linked list is empty? No, not empty. Okay, so this condition will not true. Then we will execute this condition. So here list is not empty. Tail dot next equals to 20, because it's a new element. Tail dot next is 20. So we are going to update tail is 20 here. Okay, so here head will become 10 and tail will become 20. Okay, so it will become like 10 arrow 20, and its length increase by 1, so it will become 20. Again, if you want to add 30, so list we can check list is empty. No, this condition is fail, so we are going to move on this condition. Okay, self dot tail dot next, we can check here. So self dot tail next element, what is 330. Okay, self dot tail dot next means 30. Okay, so we are going to update this tail will self dot tail equals to 30, that is new element. Okay, so here head equals to 10 and tail equals to 30, and linked list will become 10 arrow 30 arrow, sorry, arrow 10 arrow 20 arrow 30, and length is equals to 3, because every time we increase length by 1. Now we are going to define one method, prepend. Prepend means we are going to element in the beginning. With the help of append, we are going to add element in the end. Okay, so you can see here we are going to start with empty link list. Okay, length is 0. We add 30, so head and tail will become 30 at same point. We have add and tail. Okay, now we are going to append 20 in the beginning. Okay, before we are going to add in last, we will add in last. Sorry, we add it in last. Okay, 10 and 20 here, but here we are going to add in the beginning. Okay, so after 30, I'm going to add here. So 20 will become head and tail is still 30. Okay, so this is the new head. I'm going to add again 10. So 10 will become head and same 20 and 30. 30 will become tail. New head is 10 and tail is the same. Okay, so here you can see we have empty. Again, I'm going to explain again. So head is none and tail is also none and length is 0. Okay, prepend, we are going to add 30. Okay, so head will become 30 and tail will become 30, and length is equals to 0. Okay, I'm going to add 20 before 30. So head will become 20 and 30 is tail. Length is equals to 0. I'm going to add 10 before the 20. So here 10 will become head, 20 and 30 will become 10, and length increase by 1, so it will become 3. Okay, length increase by 1 every time. append and pretend. Okay, so here I'm going to use pretend. I'm going to define function name def pretend prepend, sorry, pretend, not pretend. Okay, here I'm going to pass self comma value. These are this is the parameter value. I'm going to add value one by one, like 30, 20. Okay, so new node equals to node that is 10 or whatever. Okay, so that is value. Okay, so here I'm going to write condition if self dot head is, if self dot head is none, if self dot head is none, self dot head is none, then we are going to create these things. I'm not going to write again, I just need to copy from here. Copy. Oh, where is it, yeah? Here, okay. Okay, so oh, I need to remove one. Okay, so here if self dot head is none, so self dot head will become new node, and self dot tail will become new node. Okay, so if we don't have any element inside the linked list, so we are going to add new node. Okay, so initially we have empty linked list. Okay, head none, tail none. Okay, so everything is none, length is 0. Now we are going to add, here you can see 10. Okay, create a node 10. So here new node equals to node and value it's equals to mm, anything, like you need to create 10. So here it is the 10. So head is none. Now previous condition is head is none, now head will become 10 and both are 10. Here 10 and tail is also 10. Okay, so head equals to 10 and tail equals to 10. Linked list is 10 and length will become 1 after adding this. Okay, now if this condition is false, now this condition will execute. So new node equals to new node. Okay, so here after 10 I'm going to use new node inside this 10. Okay, so here linked list is 10, I'm going to add 20. Okay guys, so 20 is new node. Okay, so here value equals to 20, I'm going to add 20 here. So new node dot next, previously we have 10, now new node dot next means 20. Self dot head means previously we have 10. Okay, now our new node, what is the new node? New node is 20. Here new node dot next equals to 20. Okay, so I am going to add this 20 in the head, so it will become 20 and 10 like this. Okay, I hope you got it, because we are going to add new node in the head, so it will become 20 arrow 10. Okay, so you can see here create a node 20. Okay, and head is not none, so 20 dot new next. Okay, so you can see here new node means 20. Here I can also write this condition 20 dot next. Okay, equals to 10 because head is 10. Self dot head 20. Here you can see 20 dot next equals to 10. Okay, now head will become 20. Okay, so here comma head equals to 20. Okay, head equals to 20. Head equals to 20 and tail will become 10 because tail 10 is the last element. I add before 10, that is I add the value before the tail, so that is head equals to 20 and tail equals to 10. Okay, now again I am going to, after adding 20, I am going to create that it is self. Sorry, that is it is head. Okay, so self dot head. Now head. What is the head? Now after adding 20, so 20 will become head. So self dot head equals to new node. What is the new node? New node is 20. So now this 20 will become head because it is the first element. 20 is head. Okay, here you can see I already explained. Head equals to 20 and its length increased by 1. Guys, I am trying very hard. Hope you guys understand everything. Self and dot length length increase by 1. Self increase by 1. Self dot length. Okay, I hope you got it. Okay, guys, so previously self dot head is none, so we need to create self dot head equals to new node and self dot equals to new node, that is 10. Okay, after adding 10 I am going to add. Okay, so this 10 is tail and head both. Okay, now I am going to add 20 before the 10. Okay, so new node is equals to 20 and next, and before we have self dot head equals to 10. Okay, after creating this, okay, so I am going to replace that this 20 now will become head. Okay, so this is the new node, this will become head here. Okay, so here I wrote head equals to 20 and tail equals to 10. Okay, so linked list will become 10 arrow, sorry, 20 arrow 10 and length is 2. Okay, now you can add 30. So here value equals to 30. Okay, you can check self dot head is none. No, it is not none, so we need to move here in else condition. Okay, so here now new node, what is the new node? New node is here I'm going to write now new node is 30 dot next is 20. Okay, now we need to set head will become 30. Okay, and tail is still same, that is 10. Okay, guys, I hope you got it. And here increase length by 1. Okay, so here new head will become 30 like this. Okay, guys, so head equals to 30 and tail equals to 10 and length equals to 30 10 3 3, sorry, no, increase by 1, so every time increase it by 1. Okay, now we moved on. Insert the method. Insert method means we are going to insert element. Okay, so first of all insert at the index 0. Okay, so we are going to insert element at index 0. Okay, so initialize head equals to 20, arrow 30, arrow 40, and tail, this is the tail, or you can say null. So new node equals to node 10. Okay, so you need to check self dot head is none. So first of all I need to create one thing. Okay, this is the very Okay, so first of all, I need to create node and insert method. I need to copy from here. Okay, guys, I'm going to explain everything. Attention here, keep attention over here. Okay, so this is the function insert. Okay, here this is the self and this is the index and value. Okay, because we are going to insert element at the index, like first index, last index, whatever. Okay, so first of all, I need to check boundary check. Okay, index should be greater than 0. Okay, if you have index in minus, so it will give you error. Or index is greater than length of self dot length, means length of linked list. Okay, so its length is like index should be greater than the length. Okay, and index should be greater than 0, should be, sorry, index should be less than 0. If index should be less than 0, or index is greater than self dot length, then it will raise the error. So exception error, index is out of a bond. Okay, so if you have index is greater than length, then it will give you error, length of linked list. Obviously, if you have lots of index, like and its length, like if you want to add index 50 index. Okay, if you want to add at index 50, value is 100. Okay, then if your linked list length is 4 or 5, then it will wrong, right? So index should be greater than, sorry, if index should be less than to the length. Okay, so here index, if index is greater than self dot length or length of linked list, then it will raise the error. Or if index is less than 0, means if you have index in minus 1, minus 2, so how will it work? Okay, so it will give you error, index is out of 1. Okay, and this is for new node. I'm going to create node. Okay, node, new node means value means number, any number, 10, 20, 30, whatever is your linked list has. Okay, and after this I am going to create I'm going to insert in empty linked list. Okay, so I need to copy this line. I not I'm sorry, I do not need to write here. I'm just to copy and I'm going to paste here. Okay, so self dot head is none, like we have empty linked list. Okay, we don't have any head or tail, so self dot head is none. Okay, so we are going to create self dot head equals to new node and self dot tail equals to new node. Inside the node, in this new node we can pass any value like 10. Okay, same here. Okay, so it is for empty linked list. Okay, so we can insert like this, and here I'm going to insert at the beginning. Beginning means शुरुआती दौर. We are going to insert element in the beginning. So here, if those condition will fail, if index is less than 0 or index is greater than length, okay, or if you don't have any empty linked list, then we need to execute this condition. Insert at the beginning. Okay, so it will give you index equals to 0. Here you can see, if we have, where insert at the index 0. We have linked list like this, had 20, 30, and 40. Okay, and new node equals to 10. I'm going to add in the beginning before the 20. Okay, so it will become 10 and none. Okay, so new node will become 10. So self dot head is none. Okay, so we can check if self dot head is none. No, we have 20 here, so this is false. Or you can say we have 10, or we are going to add 10 here. Okay, so lf index equals to 0, so this condition is to be true. From here you can see we are going to add at index 0, so lf index equals to 0, so this condition is true because we are going to add at index 0. So new node dot next self dot head, 10 is our new node. Okay, new node dot next equals to self dot head, that is 20, like this. And self dot head equals to new node. So here I already explained everything. Actually I did for I did, I already did code for this. Okay, so now index equals to 0. I'm going to add at index 0. So twenty before we have 20, 30, and 40. I'm going to add 10, that is new node. 10 equals to new node, so I'm going to add 10. So 10 dot next, 10 is new node. 10 dot next equals to 20, because 20 is head. Okay, now this 10 will become head. Okay, so we are going to update here, because before 20 we had 10. Now linked list will become what? Linked list will become like this: 10 arrow, 20 arrow, 30 arrow, 40. Okay, now this 10 is become head. So here we need to update self dot head equals to new node, that is 10. Now 10 is our head. Okay, I hope you got it. This is for inserting the element at the beginning. Okay, I'm going to explain it again with another example. Insert at the beginning. So I have 5. I'm going to insert 5 at index 0. For example, we are going to insert 5 at index 0. Or this is our previous linked list, that is 10, 20, and 30. Okay, so we are going to create node 5. So first of all, here create node 5 here. So value is equals to 5. Okay, then then resulting linked list is 5. Okay, so new node dot next equals to head. Okay, so new node equals to 5. 5 dot next equals to head. Previously we have 10 here. Okay, so it will become 5 arrow 10. So resulting new list, linked list 5, 10, 20, and 30 with the arrows. Okay, so now new head will become 5, or linked list like this, and we increase the length. Its length. Okay, in last we increase the length, its length of it. Okay. So here we can also increase its length. Self dot length, leng, length increase by 1. Okay guys, so now length is increased by 1, or be append, be insert element at the beginning. Okay, now we are going to use insert the element at the end. Okay, so I need to copy this condition here. Okay, so here inside the element at the end, band index equals to length. Okay, if we have index equals to length, so we are going to insert at the end. So here you can see in this example, mm, insert at the end. Okay, suppose we have a linked list like this: 10, 20, and 30. Okay, we are going to insert 40 at the index equals to length. Okay, means and index is equals to length of linked list. So we are going to add here. Okay, we have 3 its length is 3. 1, 2, 3. Okay, and also we can calculate its index: 0, 1, 2, and 3. At index 3 we want to add 40. Its length is 3 and index is also 3, so I want to add 40 at index 3. Okay, this is the last index of linked list, so we are going to insert at the end. Okay, so first of all I create the node 40. Okay, here in this step I need to create node that is 40. You can say wall below, whatever, that is 40. Okay, I'm going to remove. I don't need to write. So first of all, I need to create value that is 40 on node. Okay, so I'm going to add inside the in the end. Okay, so tell dot next means tell is 30. You can see here tell is 30 dot next. Okay, tell 30 dot next equals to new node, so 40. I'm going to add 40 here, baby. So it will become 10, 20, 30, and 40. This is our new element, new node. Okay, so after it will become new, I mean it will become tell. So here I'm going to update tell equals to new node. Okay, so that's it. So tell is 40 and linked list is like this. Okay, so increase length by 1 and final linked list result 10, 20, and 30. Okay, I'm going to write, I'm going to explain with the code. Okay, so length index is equals to length of linked list. Okay, that is 3. I already calculate. And self dot tell dot next equals to new node. So what we have element inside this linked list, we have 10, 20, and 30. I need to copy this. Okay, if we have linked list like this, okay, so it is the length equals to index, both are same, that is 3. Okay, and you have linked list like this. Okay, 10, 20, and 30. Okay, but I have new node that is 40, this new node. Okay, that is 40. New node is 40, so I am going to add new node in the end after 30. Okay, so here I'm going to write comma new node, new underscore node equals to 40. Okay, so here you can see here self self dot tell dot next equals to new node. So here in this self dot next, sorry, self dot tell dot next equals to new node, that is 30. So here in tell what we have, 30, this element. So self dot tell means 30 dot next is equals to new node, that is 40. Okay guys, I need to write here. Okay guys, so here you can see self dot next. So sorry, self dot tell. Tell means 30 because we have 30 here in tell, and dot next. So after 30 we have next, and next element, and new element is 40. So it will become here 40 like this. So now new linked list will become like this. Here I need to write, I can write here or you can write here. Okay, I can write here. So new linked list will become 40. I add 40 here by using this line. Okay, now we are going to update this. Okay, so this new node that is 40, so it will become tell. Okay, so now tell equals to 40. Okay, so self dot tell is equals to 40. Okay, now we said that 40 is new tell. Okay, and we increase its length. Okay guys, I hope you got it, how to add element at the end of linked list. Okay, with the help of this code we add the element in the end of linked list. Okay, or you can, I'm going to explain again. Mm-mm. Insert at the end. Okay, so we have 10, 20, and 30. Okay, we have index, different index. At index 0 we have 10, at index 1 we have 20, at index 2 we have 30. Okay, for example, this is the linked list. Okay, so new node equals to 40. I took 40 is the new node. Okay, so here temp node equals to self dot head, that is 10. Okay, this one, this is the head. I'm going to take another example, not same. Okay, so this is the 10. 10 will become temp node equals to self dot head, that is 10. Okay, for I in the range of, oh, this is at the end. Mhm. 3 minus 1. Okay, guys, I'm not going to use this condition. Okay, I hope this is the another insert at the end. Let me check. Okay, guys, this is the another. I put wrong dry run here. Okay, so you don't need to check this. Okay, I hope you got it. How to insert element at the end of linked list. Okay, now we are going to insert element in the middle of linked list. Okay, so here I need to copy these things. I need to paste it here. Insert at the middle. In the middle. Okay, so here temp node equals to self dot head. Here you can see. And this is for at the end. Okay, insert at the middle. Okay, like if you have a, before you have linked list like this, a and arrow and c. Okay, so we need to insert b between a and c, in between a and c. Okay, so b dot next equals to a dot next, because we want to insert b in between a and c. Okay, so b dot next equals to a dot next, so that is b b dot next equals to, so this is the b, and a dot next, after a we have in next c, so it will become b arrow c. Now a dot next, this one, a dot next equals to b. Okay, so this is like result, a arrow b arrow c. Okay, so original linked list, like we have 10, 20, 30, and 40, and null in last. So this is the first element that is head. Okay, if we are going to insert at the index 2, okay, this is the 30 at index 2, and we have 40 as a tail. Okay, so first of all you need to create node. We are going to add 25 in the index 2. Okay, so 25 is not connected at, so find the position before index 2. Okay, so start at the head. Okay, so head is 10. Okay, to move one step, 20, this is the move the one step, that is 20. You can see here 20. 20 is the index minus 1. Okay, so we have 2 index equals to 2, so index equals to 2 minus 1, so I got 1. So at index 1 we have what, we have 20. Okay, and connect 25, what, 20 point to the 20 point to the 30, so 25 will connect to the 30, and connect 20 to the 25, so 20 arrow 25 and 30, so link list will become 20, 20, 25, 20, 30, and 40. Okay, I will explain everything, wait a minute. Okay, first of all we are going to take another example. Create a node 15. Okay, so insert in the middle. So example, I'm going to insert 15 at index 1. Okay, so before we have linked list like 20, this one, 10, 20, 30, 40, this one. Okay, so here new node dust next, sorry, insert this temp node equals to self dot head. Okay, so before we have linked list like this, 10, 20, and 30, and 40. Okay, so temp node equals to 10, this head. Okay, so I am going to insert what, I'm going to insert 15 at index 1. Okay, so we are going to create new node, that is 15 here. By using this line we are going to create new node, that is 15, this line, by using this line. Okay, so our new node is 15. Create a new node, that is 15. Okay, now I'm going to use for loop traverse to index minus 1 node. Okay, so here in this loop you can see here, where is my loop, this loop. Okay, I'm going to insert at index 1. Okay, so index equals to 1. So 1 minus 1 it will become 0. I got 0. So at index 0, what we have? We have 10. Okay, what do we have? We have 10. So temp node, this is the 10. 10 is temp node. Okay, so here you can see we need to stop at 10. Okay, so linked list is like this: 10, 20, and 30. Okay, as it is. Now new node dot next, temp dot next. Okay, so here we are going to stop at 10. Okay, here, because we find out at index 1 minus 1, that is 0. So temp node equals to temp node dot next. Temp dot next means this one, 20. Okay, we need to stop here, and I find out temp node dot next, that is 20. Temp node dot next, that is 20. Okay, so temp node dot next is 20, and here I am going to add new node dot next. Means new node is what? 15. 15 our new node. New node dot next equals to temp node dot next, means 20. Okay, so our linked list will become like this: 10, 20, and 30. Sorry, 15. Oh, I need to copy from here. So our linked list will become after this: temp node dot, sorry, temp new node dot next and temp node dot next to 15 and 20. So we add, so this is our new linked list. Here 10, and I'm going to add 15, 15 here. Okay, to 10, 15, 20, and 30. New node dot next, that is 15 dot next and temp node dot next. Okay, so here I add 15 before the temp dot next. Okay, because I already stop at 10 here. We don't need to explain this. Okay, so temp node dot next equals to new node. Okay, so temp dot next equals to new node, so it will become 10 and 15. I add 10 and 15 here. Temp node dot next equals to new node. So before we have temp equals to 10. So like this: 10, 10, I'm going to add 10 with 15. Okay, in this line I add 15 with 20. Okay, new node, that is 15, and temp node dot next is equals to 20. So I am going to add here what? 15 with 20. Okay, so this is the 15, and here I'm going to add 15 with 20, and here in this line I'm going to add 15 with 20, and here in this line temp node dot next, that is new node, equals to new node. Okay, so I'm going to add temp node, that is 10 with 15. Okay guys, it is confusing, but you will if you are going to practice, then you can do it. Okay, so now we add 10 with 15. Okay, so it will become 10, 15, 20, 30, and 40. So tail updated, no. Unchanged tail. Okay, and increase length by 1. Final linked list will become 10, 15, 20, and 30, and 40. Okay, here length increase by 1. If new node dot next is none, then self dot tail equals to new node. Okay, so I hope you got it. Now we are going to use traverse method. Traverse means we just print the, like we just go through the every element from the linked list. Okay, traverse means, so like if you have current linked list like this, 10, 20, 30, and 40. Okay, so this is our current element, that is 10. Or you can say this is also head, but here I'm going to create one variable that is also current, and this is equals to 10. Okay, and here tail is 40 and null. Okay, so current, now here you can see current equals to 10. Again, if we are going to move this current in 20, so current will become 20. Okay, current 20, 30, and 40. And now if we are going to move this current on 30, so current equals to 30. Okay, so that's why I need to create one variable that is current, because we are going to traverse all element one by one. I means you need to reach every element one by one by using current. Okay, you first of all you need to take current equals to 10, current equals to 20 in second step, current equals to 30 in third step, current equals to 14 fourth step, step 4, and current equals to null in last step, and loop will be end. Okay, so this is called a traverse. We need to go in every element. So initially linked list had tail and length equals to 4, because we have 4 elements inside the linked list, 1, 2, 3, 4, 10, 20, 30, 40. Okay, so node 10 value equals to 10. Okay, next will connect to the node 20. Okay, value equals to 20, and next equals to node connect with the 30. Value equals to 30, and it will connect to the node 4, that is value to 4, and next equals to none. Here current equals to 10 and step 1, current equals to 20 in step 2, current equals to 30 in step 3, and current equals to 40 in step 4. Okay, so current point equals to head equals to 10. Okay, so here what I'm going to write code, it is very easy and simple. So define traverse, traverse, traverse. I'm going to pass self, and here I'm going to use current. Okay, so initially we have current equals to self dot head. Okay, start from the head, we are going to start from head equals to 10. Okay, and here I'm going to use while loop. So while current is not none. Okay, keep going until end. Okay, because current is not none, we have 10, 20, 30, current is not none, so keep going till the end. Okay, I'm going to print current dot value. So current dot value, what we have, 10, so it will print 10. Okay, so here it will print 10, and here I'm going to write, I'm going to increase current by next. Okay, so current equals to current dot next, it is used to move the next node. Okay, so this is step like start from the head, we have head equals to 10 in this table. Okay, and while current is not none. Okay, we are going to use this loop for current, because we have current equals to 10 and this is not none. Okay, so you can see here we have 10 in head. Okay, so print value is 10, it will print 10 here. Okay, and after this we have next value, that is 20. Okay, so this is the new current after 10, current equals to we have 20. Okay, because we are going to use loop. Okay, so now 20, so we are going to check current is not none. Okay, not none, so we that will print 20. Okay, one by one, 10, 20, condition current is equals to not none. Okay, yes, now again we are going to take head equals I mean current equals to 20, and print value is 20. Now next current will become 30. Okay, so current is not equals to none, so here it will print 30. Current equals to, if you are going to take 30, so we are going to check if current is not none. Yes, it is not none, so it will print 30. Okay, and yes, it will take element one by one. Current dot next equals to, like after 10 we have 20 and 30. Okay, after 30 we don't have any element, so loop will be end here. I hope you got it. So after 10, like first of all you need to 10 current equals to, then it will print the 10. And after 10 you need to check that current equals to current dot next we have 20. Okay, now you can check head will become 20 and current will become 20. And you can check current is not none, no, so it will print 20. Okay, now again you can check current equals to current dot next, yes, in next element is 30. Okay, then head will become current equals to 30 and head will also 30. Okay, so current 30 is not none. Okay, we have 30, so that is not none, so it will print 30. I hope you got it. This will give you results like this: 10, 20 and 30. Okay, so this is the very simple method, that is traverse element. Okay, now we are going to use search method and return the index. Okay, so wait a minute. Search. Okay, so current equals to head and index equals to 0. Okay, so you can see here in picture current equals to 10. Okay, and in middle we have 10, 20. Sorry, after 10 we have 20 and 30, and last element is 40. Okay, so current is equals to 10, that is index 0. Okay, so we are going to search for 30, this element. Okay, so current equals to 10 and value equals to 10. This is at present at index 0. So we are going to compare this index at what we have at index 0, that is 10, is equals to this 30. Target equals to 30. So no, this is not equal. Both are not equal and we move. We need to take current equals to 20. Okay, so value is 20 and its index is 1, because we have 20 at index 1. So we need to compare this 20 is equals to 30. No, we need to move. Okay, again we are going to take current equals to 30, value equals to 30 and index equals to 2. We need to compare 30 is equals to 30. Yes, then return it in next, that is 2. Okay, okay, I hope you got it. So here I am going to write code for search element. Actually I already have this. Okay, I need to check current self dot head index equals to by index is not none. If current equals to value, that is target return index, and current value equals to index dot next index increase by 1. Okay, okay, I need to copy this. Okay, so I am going to search target element, that is 30. Okay, so this is our parameter. Okay, and this is the function name. I'm going to pass target here as a parameter. Okay, so I'm going to search 30. Okay, so current element we are going to check current equals to 10. Okay, or you can say we have 10, that is current element. Looking at 10, at its index is 0, and we are going to compare that 10 equals to 30. Okay, so here I am going to take current element, that is 10. Okay, its index is 0. Okay, so while current is not none, yes, we have 10, it is not none. Okay, so current value is equals to target. So we are going to check here. The current is 10. 10 is equals to 30. No, this condition is wrong. Okay, this is false. Okay, current dot value is equals to target is 30, so this condition will fail. Okay, so we need to skip this. Now we move current equals to current dot next element is after 10 we have 20. Okay, here you can see now current will become 20 equals to current. So current equals to 20 and index is 1, because we have 1 at, sorry, at index 1 we have 20. Okay, so now we are going to compare again. 20 is equals to 30. No, so here current element will become, here next is equals to 20, so current will become 20. Again we are going to check this condition. Current is not none, yes, 20 is not none because we have 20. So current value now, current value is what, 20. So current dot value 20, I'm going to compare here. 20 is equals to 30. Condition is also false. Okay, so now we are going to check again. Current will become next element. So here you can see now current will become 30. So look at 30 and index is 2. Okay, we have 30 at index 2. Now we can check 30 is equals to target. Yes, this is equals to target. Okay, so here next element is 30. Okay, current equals to 30. So we can check current is not none. Yes, not none. We are going to check this condition. This 30 is equals to this current means 30, current equals to 30, and this equals to target. Target is also 30. Okay, this condition will true. Then it will return this index, that is what? That is 2. Okay, here and increase the index every time after 10, 20, and whatever, and it will if we will not find out our index that is equals sorry, that is that current equals to with the target, then it will return -1. Okay, so it will increase the index every time. If you take 10, okay, then we will check that 10 equals to 30. No. Okay, then this condition will fail, and then it will increase the current increase one, sorry, current equals to next element. Okay, and index increase one. Again it will take current dot next equals to 20. Okay, so we need to check this condition. So current is not equals to target, then it will increase its length. Then we need to check another element, that is 30, current equals to next element. Okay, and it increases length. Okay, so we need to check every time. If everything is fail, then it will return -1. Okay, so I hope you got it. Searching, how to search element. If not found any element. Okay, so like if we have 10, 20, and 30, and current element is 10. Okay, so we are going to check that 10 is equals to 50. So move and move, and it will end the current is none and return it -1 not found. Okay, because 50 is not present here. Okay, guys, if you want to print this, so first of all, you need to create node. I will explain everything previously, and you need to create list, and you need to append the element. Okay, because initially we don't have any element inside the linked list. Okay, so you need to add element inside the linked list. Then you need to search by using search method. Okay, I already explained everything, or you can print like this. Okay, so here these are the, this is the object of linked list class. Okay, so this is the linked list class. Okay, and here I'm going to append 10, 20, and 30. Okay, so if you are going to search element 20, so here this is the function name l1 dot search. Okay, this is the object name, so I'm going to search 20 and 30, so you got your result. Okay, like this. Okay, here you can search also 40, so you don't have any 40 because you add append only two element, sorry, three element, 10, 20, and 30. 50 is not, 40 is not present, so that's why it will give you -1. Here you can see, here I have -1. Okay. Mm-hmm. Okay, so if you want to run everything by using search, so first of all you need to create node, because we have initially empty linked list, or you need to create first of all linked list class, and then you need to add element. Okay, if you don't have any element, then you need to add, then you need to search, and then you need to create object and add, and then print. This is for example usage, or you can say for testing purpose. Okay, guys, now we are going to use get method. Okay, so here start with the get index. Okay, so index equals to -1. If index equals to -1, okay, s then return tell, and if no, okay, so get method start get index. Okay, so if index equals to -1, if s return tell, if no, then you need to follow this. Index is less than -1, or index is greater than the length of linked list. You need to check this. Okay, if s return none, if no, then you need to follow this. Current equals to head, and for I in the range of index, and current equals to current dot next, and return the current. Okay, I will explain everything, you will get it. Okay, so get last index by using index equals to -1. Okay, so here I have list equals to 10, 20, 30, and 40, and head equals to 10, and tail equals to 40. Okay, so I want to get index -1, so it will return tail, not directly. Okay, because I want index from the last. Okay, so it will give you result node 40. Okay, if you have invalid index, okay, 10, 20, and 30. Okay, length is 30, so get 5 means if you want to element at index 5. So index is greater than equals to length. Okay, so 5, I have 5 index here. I want to get the index at, sorry, at 5. Okay, so 5 is greater than 3 because its length is 3, 1, 2, 3, and you want to search at index 5. No, we don't have any index 5. Okay, so this is the invalid index. Okay, so like if you write like this, get minus 2 index. Okay, so you need to check index is less than minus 1, like this, minus 2 is less than minus 1. Okay, so this is also print the result none. Get node at at a specific index. Okay, so here we have 10, 20, 30, and 40. Index 0 we have 10, at index 1 we have 20, at index 2 we have 30, at index 3 we have 40. Okay, finding node at index 2. So here you can see here current equals to 10, 20, 30, 40, null, and head. So this is the first point, that is current, and head is also 10. Sorry, current is equals to 10 and head is equals to 10. Okay, so in loop 1 current arrow 20, 30, 40, and null, and loop 2 current equals to, after, like, first of all we have current equals to 10. Now current will become 20, current will become 30 here. Okay, and return this node. Okay, we will understand everything. Get node at a specific index, like this. Okay, finding the node at index 0. Okay, so if we have had 10, 20, 30, null, so no iteration because we use range 0, and return current immediately, that is index 10. Okay, so here I'm going to write code. This is also very easy. Okay, I'm going to define one function, define get. I'm going to define here get self comma index. Okay, we are going to use index here, a special case, get the last node index equals to minus 1. Okay, so if index equals to minus 1, okay, so we will get last index, it will return tail. I hope you got it, guys. It will return self dot tail. Okay, this is for last index because minus 1 is the last index in linked list, and if you are going to return minus 1 index, so it will give you tail. Okay, I already explained. Okay, so this will give you last index, that is tail. Okay, check if the index is out of bound. Okay, so elif index is less than minus 1, or index is greater than equals to self dot length. If index is less than minus 1, or oh, I miss n here. Okay, or index is greater than equals to self dot length column. Okay, then return none because it is invalid, or you can say out of one. Index is less than minus 1, or index is greater than self dot length. Okay, I already explained these things. Invalid index. Okay, we have length equals to 3, or you said that I want to access index 5. Okay, because we don't have any element at index 5, we don't have any index 5. Okay, so it is said that like this, 5 is greater than 3, so return none. Okay, or you can check that if we have, if we use, if we want to get at minus 2, so index should be not in minus. Okay, so it will give return none. Okay, and here traverse to find the node at index. Okay, in third state. Okay, I wrote here invalid index, or you can say index is out of bound. If index is out of bound, and this condition is for what? Get the last node. get last node. Okay, and here I'm going to write for third, that is traverse to find the node at index. Traverse to find node at index. Okay, so here I'm going to create current. I already explained current equals to self dot head. Okay, and oh, I forget equal. And here I'm going to use loop for dash in range index. So current equals to current dot next. Okay, so traverse to find the node at index. Okay, so if you have find out node at index, like I'm going to find out node at index 2. Okay, so first of all, 10 is current node. Okay, here if we have 10, okay, then it will use for loop. Okay, okay, one by one this loop will go through 10, 20, and 30, and after current equals to current dot next we have 20, so it will check every element. Okay, it will go through 10, 20, 30 like this. Okay, now now return the found node. Here it will return found node, that is current. Okay, okay guys, I already explained this thing. Okay, so if you want to found at index 2, okay, so you need to check like this, current equals to 10. Okay, after this you need to check current equals to 20. Okay, again you need to check current equals to 30 and return this node. Okay, so we are going to find out at index 2. Where is my code? Okay, here index 2 we have 30. Okay, so it will return current index, sorry, current, that is 30. Okay, similarly you can use like this. If we have index equals to 20, loop will go through. Initially I have dash equals to 0, so final node equals to 10. Again I need to take current equals to 10 and current dot next equals to 20. Okay, so here it will become 10, 20. So at index, I mean node at node 0 we have, sorry, at index 0 we have 10, at index 1 we have 20. Okay, so this is the final node. Here again if you are going to move, so at index 1 we have 20 and at index 2 we have 30, so it will final node, and this is also tail. This is our result. Okay, return the node at given index and handle negative index also minus index minus 1 or for the tail. Return none for invalid index. Now if you want to run fully this code, so first of all you need to create node, I already explained, and you need to create linked list. Okay, and then you need to append, and then you need to get element like this. Okay, I already explained everything one by one. Okay, and then you need to create one object for linked list, and you need to append element in example, and you need to get every element like this. Okay, L1 dot get 0 dot value, so you get here. Okay, at index 3 we don't have anything, so that's why it will run none. It will give you run. Okay, now we use set value method. Okay, so here, where there. Okay, I already have code in set value. So this is the function name set value. I'm going to pass index and value. Okay, so here you can see what is the set value. Okay, like we have a b c and d in linked list. Okay, we want to set value at index 1 x. Okay, it's mean we are going to add at index 1 x. We want to add this x at index 1. So what we have at index 1? At index 0 we have a, at index 1 we have b. So in place of b, we want to add this x, and we need to shift our index b. Okay, so first of all get index 1. Okay, so first of all I need to find out this index 1. Okay, and return the b. Okay, now we want to add at index. Okay, here at 1 we have b, so in place of b I want to add value that is x. Okay, now it will become a, x, c and d. Okay, and return true. If you have invalid index, okay, invalid index a b c, okay, length is 3, and you want to set the element at index 5, you want to return, sorry, you want to add 5 x at index 5. Okay, so get 5, it will return none, because we don't have any index that is 5. We have 3 element and index is 0 1 2. We have index 2 only. So if temp equals to false, this condition is false, it return false. Okay, now you need to update last node, that is index equals to minus 1. Okay, so a b c, so I want to set the value at minus 1, that is z. I want to set the z at index minus 1, means last, in last we want to add z. Okay, after c, so we need to get index, I mean we need to find out index. With the help of get method we can find out this index. Okay, and it will return c. Okay, at minus 1 what we have c, this is the tail. Then in place of c I need to add this value that is z. Okay, so a v z and return true. I hope you got it. And before set value, or you can say here I want to add at index 1 we want to add 50. Okay, so here head is 10, 20 and 30 is tail. Okay, so at index 0 we have 10, at index 1 we have 20, and at index 3, sorry, at index 2 we have 30. Okay, so I want to add at index 1 that is 50. Okay, okay, so after set 1 at 50, at index 1 50, so temp, I'm getting 1 at index 1 what we have 20, so it find out 20 here, and temp dot value is 50. Okay, so it change 20 to the 50, and new linked list like this 10 50 and 30. Okay, so we changed here. Okay, I hope you got it. I'm going to explain again. Set the value. I everything explain again. So okay, so this is the function. Here I'm going to pass index and value. Okay, if we are going to insert at index 1, that is 50. Okay, so with the help of temp equals to set get index. Okay, with the help of this I get index, that is 1. Index equals to 1. At 1 I want to update 1 with 50. At index 1 I want to put 50. Okay, so it will find out 1. Okay, now we can check if temp, so temp dot value equals to value. So in temp what we have value, so we have at index 1 what we have here, you can see I have 20. At index 1 we have 20 guys, 20. So here temp dot 20, this is 20. Mm-hmm. Oh. Okay, so we have temp dot 20, value is 20. I want to replace this 20 with value that is 50. Okay, or you can say, I did mistake here. So temp equals to 20. Okay, or you can write like this, 20 dot value equals to 50, so it will become 50 and it will return true, otherwise it will return false. I hope you got it, guys. First of all, this is used for find out the index, okay, and this is for set the value. Okay, so in place of 20 you fit 50 here. 10, 50, 30. Okay, so temp equals to get index. Okay, so I find out 20 here, get index. Okay, so here you can see at index 1 we have 20. Okay, if temp dot value, so 20 dot value, I need to replace the value with 50. Okay, so here you can see temp dot value equals to 50, so change 20 to 50. Okay, now new link list 20, 50 and 30. Okay, I hope it you got it. Or if you want to run it fully, then you need to create node. Okay, initially we don't have any node, so that's why uh, self dot value equals to value and self dot node equals to none. Okay, after this you need to create linked list. If you have zero length, like if you don't have any length or you don't have any head and tail, then you need to create like this, and you need to give head equals to none and tail equals to none and length equals to zero. Now if you have any everything is zero, then you need to append element by using this self dot node equals to new node and self dot tail equals to new node. Here you need to update or add the new node. Okay, okay. Okay, so you need to append the element one by one. And after this, you need to get the element, because get the element, with the help of get element, you find out the index. Okay, and here you need to use set. With the help of set, here you get the index by using get element get method, and here you need to replace the element. Okay, and this is the example object. L1 equals to object, and for linked list, here I'm going to append 10, 20 and 30. Okay, and here I'm going to print before update get one. Okay, so l1 dot get, I'm going to call get method that we can get the index. Okay, so get one dot value at index one, what we have 20. Here again I'm going to use this object l1 dot set value. I'm going to add 25 at index 1. Okay, and here again I'm going to find out what we have at index 1, so it will set that 1. Okay, after adding 25, again we use set value. So at index 3 we set 40, so this is the fall, because we don't have any index 3. Okay, we have at index 0 10, at index 1 we have 20, at index 3 we have, sorry, at index 2 we have 30. Okay, so we don't have index 3. This is for index 0, this is index 1, this is index 2. Okay guys, so you got response like this. Okay, I hope you got it. Now we are going to pop first. By we are going to use pop first method, means we remove the element, first element. Remove and return the first node head. Okay, handle empty list and single node and update the head and length. Handle the empty list and single node and update the head and length. Okay, so here I am going to write for code for pop first. I do not have code for pop first. Okay, so first of all I'm going to define one function, pop underscore first. First, here I'm going to pass self, comma, if self dot length length equals to 0, self dot length equals to length equals to 0, then it will return none. N1E. Okay, if length equals to 0, so how can we remove any element? Okay, so that's why it is none. Okay, if we don't have any element, then we can't remove first element from the linked list. Okay, because we don't have any linked list, it's length equals to 0, so that's why it is none. Okay, and here I'm going to write for pop node. So first, because we are going to add delete first node, so that's why, so popped underscore node equals to self dot head, because we are going to delete last element, sorry, first element, that is self dot head. Popped node equals to self dot head. Okay, so here if If self, oh, what the hell is this here? I'm going to write here, if self dot length, length is equals to 1. Okay guys, I explain everything. Wait a minute. Initially we have this linked list, okay, 10, 20, and 30 and 40. Okay, so head equals to 10 and tail equals to 40. Okay, so pop node, that is 10. I want to remove this node, okay, because pop first means we are going to remove first element from the linked list. So pop node equals to 10. Okay, so I'm going to write here pop node equals to 10. Okay, pop node equals to 10. After this we have 20, 20, and 30 and 40. Okay, so this is tail. Okay, so we move this head on 20. Okay, because we need to remove this. So we, if we remove 10, okay, this is also head, but in linked list we should have one head, so we need to shift this head from 10 on 20. Okay, so now new head will become 20, and this linked list as it is, after 20, 30, 40 on tail. Okay, so here if length, if self dot length equals to 1. Okay, so we don't have self dot length equals to 1. If you have length of linked list equals to 1, then you need to write self dot head equals to none. Okay, and similar for tail, self dot tail is also equals to none. Okay, so if you have length 1, or if you have only element that is 10, okay, so you can disconnect like this: self dot head equals to none, and self dot tail equals to none. Okay, and if you have long linked list, okay, if you have multiple element, I already show you. So here self dot head, that is 10. Okay, so first node equals to 10, and tail equals to, here I took 40. Self dot head equals to self dot head dot next. Okay, so I am going to disconnect this 10 because I don't want this. I just remove this 10 by using pop fast, so new head will become 20. So it is said that like this: what self dot head, this is the 10, self dot head equals to 10. So self dot head dot next, that is 20. Okay, this is the head, and head dot next, that is 20. Okay, so I am going to write here head equals to head dot next. Okay, so self dot head dot next, that is 20. Okay, so I got 20 here. Okay, so self, now we are going to update self dot head equals to 20, that is the next element of the head. We have head equals to 10, and we move this head on 20. So head equals to head dot next. Okay, so that is 20. From, you can see here, now 20 will become our new head. Okay, now we are going to disconnect this node, this 10. Okay, disconnect, because we want from 10, 20 to 40. Okay, so I'm going to disconnect this. So how can I disconnect this? Pop node, here I'm going to write pop node dot next. Okay, so I'm going to disconnect this buyer, that is next buyer. Buyer is also called the next. 10 is popped, and next means buyer. You can say buyer means arrow. Okay, so pop dot next means, pop dot next is equals to none. Okay, so you can say like this: pop node is 10, pop node is 10, and next means this wire or this arrow. So we need to disconnect this, and okay, we put here pop node dot next equals to none. Okay, and now We need to decrease its length by 1 because we remove 10 from beginning. Okay, self dot length minus equals to 1. Okay, we need to increase it, decrease by 1. Okay, and return popped node. Okay, after disconnecting node, our new linked list is this 20, 30, and 40. Okay, and it will return 10, that is pop node. Okay, and you can say we can took another example. Before we have 10, 20, 30, and 40. Okay, and tell is 40 and 10 is head. Okay, length equals to 40. So pop node equals to head, that is 10. Okay, first of all we have 10 in head. Okay, so head now will become head dot next. Okay, so head now update to the point 20, this one. Okay, we need to remove this. So pop node dot next equals to none. Okay, we disconnect this 10. Okay, now our new links is like this 20, 30, and 40, and length is decreased by 1, so it will become 3, and pop node will be 10, that is detached. Okay, it will return 10. I hope you got it, everything. Okay, you can say again, I'm going to explain. If you have 10, 20, and 30, its length is 3, so head equals to 10. Okay, so here you can see head equals to 10. Okay, and tail equals to 30 here, and length equals to 3. So pop node equals to head. So this is the pop node. Okay, now move 20 on 20. So this will become new head. So because we have here self dot head, it will become self dot head dot next. So 20 is our new head. Okay, and return we are going to disconnect this 10 from the linked list. So pop node dot next is none. Okay, so we need to disconnect this, and its length is decreased by 1. Okay, here you can see dot 10 dot next is none, so we are going to disconnect here. 10 dot next pop node dot next is none. Okay, so break the link and return the pop node, that is 10, and length is decreased by -1. Okay, I hope you got it, guys. Now we are going to use pop method. This is the pop first. In this we need to remove first element, and in this method, pop method, we need to remove last element. Okay, remove and return the last node from the tail, handle empty linked list and single node, and traverse to the second last node to update tail. Okay, run pop method to remove the last element. Okay, so like we have 10, 20, and 30 and tail, so length is equals to 3, so we have linked list like this. So I'm going to write code for this. Wait a minute. Here this is the method pop. Okay, if I'm going to write self, wait a minute, guys, I am tired. Okay, so self dot length length equals to 0. I need to add colons. It will return run none. Okay, guys, if you have length equals to 0 means you don't have any element, then it will return none. Okay, and here what we are going to pop node equals to tail. Before what we have pop node equals to no pop node equals to head, self dot head. Now we have self dot tail. Okay, pop node before we have head, this one. Now what we have pop node equals to self dot tail. Okay, now we are going to write the code for check the condition, that is self this condition. Okay, I'm going to check this condition again. Okay, if we have length equals to 1, so mm, if we have self dot length equals to 1, this is for 0 length. Okay, so if we have 0 length, then we need to return none, and here we have self dot length equals to 1, so we need to set both head and tail none. Okay, now in else condition we need to write code for return the last element. Okay, so here I have uh, temp dot next. is not none, is not self dot tell. Temp dot, sorry, oh, this condition is for while. Okay, so here I need to define temp. Temp equals to self dot head. Okay guys, like if we have linked list 10, 20 and 30, so this is the head, that is 10. Okay, so self dot head equals to 10. Here I'm going to write 10. Okay, and pop node is 40 because this is the last element, sorry 30, this is the last element. Okay, so for pop node equals to self dot tell means in tell we have 30. Okay, so this is for if length equals to 1, this is length, this is for length equals to 0. Okay, or if we have element, then we need to execute this condition, else condition. Okay, so self temp equals to self dot head. So now temp equals to head, so that is self dot head, that is equals to 10. Okay. This element cell temp equals to self dot head start traverse, so this is our new temp equals to 10. Okay, and temp dot next equals to 20 because it's the element next to the 10. Okay, so we are going to check temp dot next, that is 20. Temp dot next, that is 20. Okay, you can see here temp dot next is 20 is not self dot tell. Is this tell? Because we have tell equals to 30, so we are going to check that 20 is equals to the tell. No, so this condition is true. Okay, here inside the while loop I temp dot next. So what is the temp dot next is 20. 20 is not a self dot tell, so tell is 30, so this condition is false. Sorry, this condition is true because both are not equal. Okay, so we need to enter here. Here what we are going to update, so here temp equals to temp dot next. Okay, temp equals to temp dot next. So while temp dot next is not none and self dot is not, no, while temp dot next is not self dot tell, while temp dot next is not a self dot tell, check the condition. Here we have 10 in temp and temp dot next equals to 20. Okay, so both are not equal, so we need to enter inside the loop. Now temp equals to temp dot next be moved forward, so temp will become 20 and temp dot next become 30. Okay, so here temp equals to temp dot next. Okay, so before we have 10 in temp, now our 20 will become temp. Okay, and temp dot next is 30. Okay, so here temp dot next is equals to 30. So here temp equals to temp dot next equals to 20, and here this is for like if you don't have any temp dot next equals to after 30 we have none. Wait a minute, here self dot tell equals to temp. Wait a minute, I will explain everything. Self dot length 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 decrease by 1 and it will return popped node. Okay, wait a minute. Okay, so I moved temp equals to temp dot next. Okay, so 20 will become temp and temp dot next equals to 30. Okay, So here temp dot next equals to 30. It is not none. Okay. So now temp equals to 20 and 30 and tab. This is our linked list. Okay. Now again we are going to check in while loop here. Okay, we don't need to do anything here because we don't have temp because temp dot next equals to none. Okay, so we are going to check again. Temp dot next is not self dot tell. Okay, so here we are going to check condition here inside this. While temp dot next is not none and self dot condition. Okay, we are going to check condition. So here we have temp equals to 20 and temp dot next equals to 30. Here temp dot next equals to 30 is self dot tell. Okay, not next. Okay, so both are equal, so this condition is fail. Okay, so then we need to exit here here. So we need to exit this condition. Now we can check temp dot next equals to none. Yes, like 30 before after 30 we don't have any element. Okay, so this is none. Temp dot next is now none and we need to disconnect this. Okay, temp dot equals to none and cell dot tell equals to temp. So we don't have any temp. Okay, so this condition is none. Temp equals to temp dot next. Next. Okay, none. Disconnect the element now. Temp and temp dot equals to none. Temp dot next equals to none and temp equals to 20. Okay, so here self dot tell equals to temp. Updated the tell. Okay, so tell will become 20 and length decrease by 1 and return 30. Pop node is 30. Okay, guys, here you got it. I hope you got it. Okay, after 30, if we reach 30, so temp dot next is equals to none. Okay, so we need to like after get 30, so we need to like we are found out that temp dot next equals to 30 and this is also tell. So we need to disconnect this. So we got only 10 and 30 inside the linked list. Okay, we got only 10 and 30 here. After disconnecting, we got here 10 and 20. We disconnect 30. Okay, from here, and we need to replace this temp as a tail. Okay, so now new tail will become 20. Okay, and its length decrease by 1 and returning pop node that is 30. I hope you guys got it. Okay, if you have doubt then you need to follow this notebook, you will get everything. Okay, I will post this code on LinkedIn. Sorry, I sorry, I post this code on GitHub. Okay, I already have this repo. You can go and check there. Okay, now we move on return. So yeah, now we move on remove method. Okay, so here index method. Okay, so here I have list 10, 20, 30, and 40 and length is equals to 4, index equals to 2. I want to remove index 2 that has value 30. Okay, so first of all I'm going to write code define remove. Here I'm going to pass self comma index, and here if index is less than -1 or index is greater than equals to self dot length length, then it will return none. Wait a minute, I will explain everything each step. Okay, if length if index is equals to 0, then we need to return self dot pop first. If you have index to 0, then it will return first element by using pop first method. I already explained pop first method. It is used for sorry, it is used for delete the element from the first index. Okay, I'm going to call this method here. Or if you have, if index in dex equals to -1, or index equals to self dot length -1, so it will return self dot last index. Okay, I will explain everything here. Previous node equals to self dot get index -1. Okay guys, I'm going to explain till now. Okay, so if you want to remove element from the linked list, you need to use remove method. Okay, here I need to pass index. Okay, if your index is less than -1 or index is greater than length of linked list, okay, I already explained these things. Okay, so it will return none. Okay, you can think like this: if index is greater than equals to length of linked list, then it will return none. Okay, if you have index equals to 1 0, okay, then you need to return this self dot pop first, then it will remove first element whatever you have in linked list. Okay, and if you have index equals to minus, or index equals to self dot length -1, okay, so then it will use return self dot pop, means it will remove the last element. If you have index equals to -1, or you can say index equals to length -1, then it will use pop method that remove the last element from the linked list. It is used for remove the last element from the linked list, and it is used for remove the first element of the linked list. Or if you have invalid index, then it will return none. Okay, so here you can see. Okay, so here I have 10, 20, 30, and 14 linked list. Okay, so this is the previous node 20, and this is the target. Okay, so find the previous node, get index 1. So 0 1 at index, get index 1, but we have 20. Okay, and target equals to previous node dot next, means 30. This one, this is the target, this is the previous index node, and this is the target node. Okay, so here previous node equals to get 1. Okay, so I got 20, and target equals to previous node dot next. Okay, so this is the previous node, and next of this we have 30. Okay, we find out 30. Now we are going to connect 20 to the 30. Okay, because we are going to remove this 30. Okay, so we are going to connect this 20 to the 40. Okay, so connect 20 to the 40 and bypass 30. Okay, we just bypass 30. Okay, and isolate 30. Okay, that is null. And final 20, 30, and 40. 30 is disconnected. Okay, I hope you got it. So here previous node, that is self dot get index. Okay, so we want to 0 1, we want to add at 1 index 1. Okay, so previous node we are going to find out. Okay, so we have index 1, so find the previous node, that is get 1. Okay, like we have here, we have index equals to 2 and value equals to 3. This one 0 1 2, we want to remove this index equals to 2 and value equals to 30. This is index, or we have length equals to 4. So here I need to calculate its. So here what we get, 2 minus 1, because we have index equals to 2. So what we get equals to, at index 1, 2 minus 1, what we got, 1. So I got 20. Okay, so this is the previous node, this is the 20. How we get this? index equals to 2, and here I'm going to use this thing. Okay, self dot get 2 minus 1, so I get 1 at index 1. What we have? 20. Now I'm going to use popped underscore node. This is the another variable. So popped node equals to previous node dot next. So previous node, what is the previous node? 20. So after 20, what we have next in the 20, next of the 20? So we have 30. So it will become 30. Okay, pop node is 30. Okay, guys. Now, now popped, sorry, previous. Now previous dot next equals to pop node dot next. Okay, so what we have? Previous node dot next 30. Okay, so here, mm, from here you can see, mm, pop node equals to previous dot next, that is 20. Previous node is 30 and pop node is 30. Okay, so previous dot next equals to pop dot next. Skip and remove the node. Okay, so previous node, where is it? Okay, here, previous node dot next equals to pop node dot next. Okay, we are in this state pop previous node dot next equals to pop dot next, line number 5 in the table. Okay, so skip and remove the node. Okay, so previous node equals to 20. Okay, and pop node equals to 30. So list will become 10, 20, and 30. We remove this 30. Skip and remove. Okay, 10, 20, and 30. Here, previous node, previous node with that is 30. Okay, so in place of this node, in place of this previous node dot next, that is pop dot next. So what we have? Pop dot next 30 के नेक्स्ट में क्या है guys? That is 40. Okay, this is the 40, and before we have 20. Okay, so we got our pop dot next. So 30 dot next, what we got here? 40. Okay, so our linked list like this: 10, 20, and 40. Pop pop node is 30. Okay, now after this, pop node dot next is none. Now we are going to replace this 30 with none. Okay, so here pop node dot next is equals to none. Disconnect and remove node, this node 30, pop node 30 is fully isolated here. Okay, now here I disconnect 30 from the linked list. Okay, now I use, sorry, after removing this 30 from the linked list, I need to decrease its length. Okay, so length before we have 4, now it will become 3. Okay, so I need to write this code: self dot len gth minus equals to 1. Okay, and return popped node. Okay, that is 3. So length is also decreased by 1, and popped node equals to 30, not 3. Okay, so I hope guys you got it. Previously, we are going to find out previous node, that is 1. At index 1, what we have? 30. Okay, now pop node equals to previous node dot next. So previously we have 20, and next of the 20 we have 30, that is pop node. Okay, so previous node dot next, what do we have? Previous node dot next equals to, we have pop node dot next. What we have? Pop node, what we have in pop node, next of pop node we have 40. Okay, so we need to disconnect this 30. Okay, and length is decreased by 1, and pop return the top pop node. Okay, I explain everything here. Okay, this is for if index is less than 1. Okay, so check the index validity. This is for if index is 0, this line. Okay, return none if we have this condition. If we have this condition, then it will use pop first. Okay. Okay, and here remove the tail. We are going to use this thing for remove the last element, or you can say tail. Index equals to 2, index equals to 2, that is not equals to last. Okay, because we are going to remove an index, that we what we have at index 2, so we have value equals to 30, so we want to remove 2. Okay, so we can check here index equals to, because we have index equals to 2. Okay, we don't have index equals to minus. So if we have index equals to minus, then we need to remove last element. And here you can check, we have index equals to 2, so t is not 2 is not equals to 0, so we need to skip these all things. Okay, because we have index equals to 2. Okay, so first of all you need to find the previous elements by using self dot get index. Okay, so this will give you 20 here. Okay, now you can find out pop node, that is equals to previous node dot next. Okay, so this will become previous node equals to 20 and pop node equals to 30. So pop node equals to 30. Okay, now you use previous underscore node equals to, sorry, dot node equals to pop dot next. Okay, so skip remove node. Okay, so here we are going to remove pop node 30. Okay, pop previous node dot next. Okay, what we have? Previous node in next of 20, what we have? That is pop node. So pop node dot next, what we have? 40. Okay, so list will become 10, 20 and 30. We remove this next. Okay, previous next and pop dot next. Okay, for example, previous next. Okay, so for example, we have like this 20 is previous node dot next. Okay, so this is the next, you think this is the next, so previous dot next we have 30, and pop dot next means we are going to pop 30 dot next, so we need to remove these things. Okay, these things from the linked list. Now linked list will become 10, 20 and 30, 40. Okay, I hope you got it. Previous node dot next, this is the next, and this is the pop node, and again this is the node, next node, next. So pop node dot next equals to none, and length is decreased by 1, and return the pop node. I hope you got it, guys. Or here you can see I have 10, 20, 30 and 40. Previous node is 20 and 30 is target. Okay, so find the previous node by using this get. I got 20 and targeted node equals to previous node dot next equals to 30, and connect 20 to the 40. Here we are going to connect 20 to the 40 by using this line. We connect disconnect it to 30 from both. Okay, and isolated 30 and 20, 30, sorry, 10, 20, 30. This is our new linked list, and 30 will be disconnected. I hope you got it. So guys, I have finished everything. I have completed. I don't know how. Okay guys, this is a linked list, whole linked list, and it's all operations. I will I mean I will solve everything. I mean I will solve lead code question in next video. Okay, based on linked list. Okay, I hope you got it. Or if you have doubt, then you can follow this notebook. I already have this code on GitHub, and I already mentioned this link in the description. Okay, Guys, this is the live session, okay? So I use live, okay? It took 2 hour 30 minutes to solve everything, every operation from linked list. Okay, now it has 2 and 30 minutes. 2 2 hour 29 minute, and sorry, 2 hour 30 minute and 2 3 second. Okay guys, I hope you like my video. If you like my video, please do subscribe, like and comments. Okay, thank you so much guys. Guys, this is a last, sorry, this is a live video. I explain everything on live. Okay, this is not a recorded video. If I did mistake here, you can see my mistake here. Okay, otherwise no problem.